Hello there, it's me again. And time to get back to tectonic plates. Now, last time I talked to you about how all of this is fueled. This time I'll tell you how it impacts you. Now, you've all heard about mountains and valleys and volcanoes and everything. This time I'm going to tell you how that all works. Last time I talked to you about convection currents, right? Well, remember how they're all moving in different fashions, like this or like this? Well, that's how they affect the tectonic plates too. They're all moving in different ways. That way it forms three different boundaries. Transform boundaries that move and slide past each other like this, like when you're rubbing your hands and you're really cold. Convergent boundaries when they're knocking heads, and divergent boundaries when they're moving apart. Come here into my chalkboard and I'll show you how that all works out. Now, when these three boundaries collide or move apart, there are 8 things that you should know that can happen. Earthquakes, volcanoes, mountains, seafloor spreading, continental drift, foldings, faults, and deep sea trenches. Okay? With convergent boundaries, the two are butting heads. Okay? Now, two things can happen when this occurs. 3, sorry. A plate could get pushed up, a plate could get pushed down, or 2 plates could get pushed up. Okay? Now, when the plates get pushed up, that will make a mountain. You know, the big, tall, pointy things? Now, when a plate is pushed down, it's in here. It's in the mantle, okay? Remember that? Big, fiery stuff with the convection currents? Now, once it's in there, it likes to heat up. It's really hot. Until finally, it pushes through the mountain and comes out as a volcano. Okay? Now, with divergent boundaries, the plates are moving apart. So that's how continental drift happened. Originally, everything was in the form of Pangea, okay? And it's spread apart because of a bunch of divergent boundaries, okay? Now, when this occurs, you can get a deep sea trench or just a valley, okay? Got this right here. This is also a small method of making a volcano. Now, this happens over thousands of years, so it's not going to be a big, huge hole like this. It's just going to be a tiny little crack, and that magma can push up. It can form volcanoes and geysers, like Old Faithful. Now, with transform boundaries, I'm going to go an overhead view of this. They're moving past each other, sliding up against each other. Now, one of the most famous ones of this is the one in California. Soon, in like 3 million years, the San Francisco and, oh my gosh, I forgot the other city. I think it was Miami. Yep, it was Miami. San Francisco and Miami are going to be right next to each other. Won't that be cool? Too bad we won't be alive. Now, since they're spreading apart, they're really tight and compact. They're gonna eventually, if a really hard rock breaks in there, it's going to send out a shock wave from that exact position. That's what scientists want to pinpoint so they can figure out where an earthquake's gonna happen. So the whole Earth shakes and everything. Now, this can also create a volcano. One of the most popular ways of creating a volcano was actually Hawaii. It's actually a transform boundary. See, as the plates move past each other, magma keeps leaking up. So it forms that little line. That's why Hawaii is in a perfect straight line. Well, that's the bulk of all you'll need to know for transform, divergent, and convergent boundaries. See you next time.